In the name of God, today I want to talk about the 3rd to 8th week. We say that the embryonic period. In the embryology, we divided the uh, pregnancy or gestation of the embryo into three phases. Pre-embryo phase or germinal phase is started from the fertilization and implantation till to formation of the three germ layers. It means till to the 3rd week of development. From the 3rd week till to the 8 weeks, we say that this phase is the embryo phase, and this times ectoderm, endoderm, and mesoderm differentiated to many tissue and organ in our body. And the last stage in the gestation is named is fetal phase. Is started from the 8 till to birth. It means from the 8th week till to 38 weeks. Now I want to talk about how the ectoderm, endoderm, and mesoderm are differentiated and making many tissue in our body. You can see here the ectodermal layer making a epithelial lining of the GI tract, some parenchyma in the thyroid, lung cells, and the mesoderm layer making muscles, skeletal, cardiac, and smooth muscles, and the blood cells and blood vessels, and bone and dermis of the skin, and the ectodermal layer making the epidermal layer of the skin, neuron, brain, spinal cord, and pigmented cells. And major events in the 3rd week: appearance of the primitive streak, development of notochord, and differentiation of germ layer. We discussed about these events in the 3rd week. But now I want to talk about the derivative of the ectodermal germ layer. At the beginning of the 3rd week of development, the ectodermal germ layer has the shape of the disc that is broader in the cephalic than broader in the cephalic than in the caudal region, as you see here. And here, as you know, under the ectodermal layer, we have a notochord in the middle layer. And the notochord, as you remember, is important for the induction of ectodermal layer, because the ectoderm situated over the notochord. As you remember, the notochord secreted three major substance or transcriptional factor. That name is a nogin, cordin, and follistatin. And these transcriptional factors causes the down regulation of the BMP4 in the ectodermal layer. As a result of this induction, the ectoderms, the cells of the ectodermal layer make up one new structure that name is a neural plate. This is a first step for the neurulations. When the ectodermal layer change to the neural plate, if you see the picture, is like a spoon or rocket shaped structure is forming here. And the next step, a one groove is appear on the midline here, on the midline of the neural plate. That name is a neural grooves. These events that's happen in the 20 days of the gestations. Here you can see that the notochord in the transverse section, the blue color is ectoderm, and this is again in the continued development here. This is neural grooves, and gradually the edge of the neural groove is named is a neural fold, and gradually the neural folds join together. And finally, when the neural fold, the edge of the neural fold join together, this part of the ectoderm separated from the remaining ectoderm, and finally we have one neural plates. Here, by detail, you can see that this process in the close-up pictures. This is a notochord. The light blue is a ectodermal layer that's making a neural tubes. Gradually, you can see that the one fold is forming here. The edge is named the neural float, and finally, this part of the ectoderms separated from the remaining ectoderm, and now we have a one tubes that name is a neural plates. For this process, the downregulation of the BMP4 exactly over the notochord is important, and some molecules that is need for the neurulation is reading these pictures. Again, the process of the neurulation, the transfer section of these events you can see in these pictures. But here, please notice to the green coloring here. There's some cells in the border between the neural plate and future epidermis or surface ectoderms here, because the remaining part of the ectodermal layer in the future development making an epiderm, and we say that this part that not participated in the formation of the neural plate is named is a surface ectoderm. This surface ectoderm making the epidermis of the skins. Please attention to the green coloring here, exactly between the neural plate and the surface ectoderm, the green color. You can see that some cells, that these cells during the closing of neural tubes or after the closing, these cells separated from the surface ectoderms and neural tubes and making a new layer. That name is a neural crest layer. In conclusion, ectodermal layer, as a result of induction of the notochord, finally making a three layers: surface ectoderms, that in the future making the epidermis of the skin, neural crest, and neural tube. The neural tubes make the central nervous system. It means made the brain, spinal cord, and the neural crest cells migrated from here to making a many tissue and cells, and I will tell you in the next slides. Here you can see again the formation of the neural tube. The yellow color is neural crest cells and is marked in here. This is a real mouse embryo. This is a neural groove, a neural fold, and some cells in the edge of the neural fold. His name is a neural crest. As I told you, the fusion of the neural fold begins in the cervical region and proceeds cranial to caudally, then form the neural tube. The neural tube is then separated from the surface ectoderms. Here you can see this process again. This is a fusion of the neural fold. As I told you, is started from the cervical region and continue to up and down like a zip. This is a real embryo. Again, the closing of neural tubes. During the closing, the neural crest cells is formed. The first of all, when the closing of the neural tube is happen, the one foramen in the anterior region of the embryo is open, and then its name is anterior neuropore, and another one in the posterior neuropore or caudal neuropore. In the future development, anterior neurocord is closed in the 25 days, and the posterior notochord is closed in the 28th day of gestations. And finally, the neurulation is ended with closure of the neuropore at the end of the 4 weeks. In conclusion, the ectodermal germ layer gives rise to organs and structures that maintain contact with the outside world: the central nervous system, the peripheral nervous system, the sensory epithelium of the ear, nose, and eye, and epidermis, including the hair and nails, subcutaneous gland, the mammillary gland, the pituitary gland, and enamel of the teeth. You can see here the real embryo, the coronal section in the mouse embryo. And here, this is a spinal cord. Here is a brain. And in the end of the 4th week, we divided the new neural tubes into 3 regions. The narrow part or caudal part is name is in the brain. His name is rhombencephalon, mesencephalon, and prosencephalon. And the lower part is a spinal cord. You can see here the coronal section of the neural tubes. Here is a spinal cord, hindbrain or rhombencephalon, mesencephalon or prosencephalon. After you can see that and detected 3 primary vesicles in the future brain. Here again is marked by the yellow color is a prosencephalon, the green color is a mesencephalon, and the blue color is a rhombencephalon. In the more development, then the 3 brain vesicles further differentiated into 5 secondary vesicles is a brain vesicle before the 5th week. And the end of the 5th week, you can see that the 3 brain vesicle differentiated to 5 brain vesicles. It means that the prosencephalon making a telencephalon and diencephalon, mesencephalon is remain without any changes, and the rhombencephalon making a metencephalon and myelencephalon. In our body, the telencephalon making the brain hemisphere, the diencephalon making the thalamus, hypothalamus, epithalamus, and subthalamus, mesencephalon making the midbrain, metencephalon making the pons and cerebellum, and the myelencephalon make medulla oblongata, and spinal cord made the spinal cord. This is a whole of the development of the brain from the neural tubes. In the 25 days, in the 40 days, you can see that 3 brain vesicles, forebrain, midbrain, and hindbrain, and spinal cord. In the more development, you can see that some expansion or enlargement in the brain vesicles. In the 100 day of the gestations, you can see that cerebral hemisphere, cerebellum, pons, and medulla. And the end of the pregnancy, in the time of the delivery, in the 9th month, you can see that the development of the brains. When the neural tube is formed, by the time of neural tube is closed, through ectodermal thickness, the otic placoid and lens placoid become visible in the cephalic region of the embryo. During further development, otic placoid will develop to structure need for hearing, and lens placoid will form the lens of the eyes. As I told you, during the closing of the neural tube, or some time after the closing of the neural tube, the green coloring here, the neural crest cells, is formed in the edge of the neural fold as a result of the intermediate concentration of the BMP4, and these cells making a different cells in our body. You can see here the neural crest cells. This is a subphase ectoderm, the neural tubes, and the purple is a neural crest cells. Here is show again, and then another pictures in the real embryo. Again show that the neural crest cells formations, the green colors. Again in the real embryo, neural crest cells and the pathway of the migrations, the neural crests. The neural crest will undergo epithelial to mesenchymal transition at it leaves the neuroectoderm by active migration and displacement to enter underlying mesoderm after closure of the neural tubes. It means that these cells have to migrate to the whole of the embryo. The neural crest cells have two pathways for the migration. That's neural crest uh, migrate to dorsal pathway through the dermis, making the melanocyte in the skins, and that's neural crest cells migrate in the ventrolateral pathway, this one, ventral or ventrolateral pathway, through the anterior half of each somite to become sensory ganglion, sympathetic and enteric neuron, Schwann cells of adrenals. Here is a neural crest cells differentiated to these cells in our body: melanocyte, adrenal, medulla of adrenal gland, skeletal and muscular component of the head. This table show that neural cell derivatives. You can see read by details. During the formation of the neural tubes, maybe we have some abnormality. That the name of this abnormality is neural tube defect, NTD, result when neural tube closure fail to occur. If the neural tube fail to close in the cranial region, the most of the brain fail to form, and defect is called anencephaly. This is anencephaly. You can see that the brain is not developing here. It is a lethal defect, and most of these cases are diagnosed prenatally, and pregnancy is terminated. Another NTD, his name is spina bifida. If closer fail anywhere from the cranial region caudally, then defect is called spina bifida. The most common site for the spina bifida to occur in the lumbosacral regions is not shown in these pictures. I want to show it. This is a spina bifida, and the common region for the formation of the spina bifida, the lumbosacral region. We have three kind of spina bifida: meningocell. This is an occulta or simple. We don't have any neurological signs. The meningocell at the spinal cord is remain in the normal site in the vertebral canals, but the meningeal layer is bulging under the skin, and the meningomyocele that the sock contain the neural tissue and spinal nerves. This is a most severe kind of spina bifida, meningomyocele. This is a cross section, spina bifida occulta. We don't, as I told you, we don't have any neurological signs, meningocele. Only we have one sock in here. Only a fluid filled sock of the meninge protrudes from the defects, and the meningomyocele include neural tissue and sock. The rachis refer to necrosis, and rachis may occur in the spinal cord or brain region of the neural tube and represent the most severe type of abnormality. For the prevention of the neural tube's defects, regardless of the region or country where NTD occur, rate have been reduced significantly following folic acid administration. For example, rates throughout the United States are now approximately 1 in the 1,500 births. And for the prevention, it is estimated that 50% to 70% on NTDs can be prevented if women take 400 microgram of folic acid daily, beginning 3 months prior to conception and continuing throughout pregnancy. And if a woman has had a child with an NTD, or if there is a history of such defect in her family, it is recommended that she take 400 microgram of folic acid daily and then 4,000 microgram per day starting 1 month before she try to become pregnant and continuing through the first 3 months of the pregnancy.